Good morning, students. We had already started the second chapter of chemistry, acids, bases and salts, and we had discussed about the action of acids and bases on different indicators and the properties of acids. The reaction of acids with metals, with metal carbonates and bicarbonates, with metal oxides and with bases. Today we will study about the properties of bases. Okay, so as we had discussed, bases are bitter in taste. Okay, they are all soapy and slippery to touch. This is a special word, soapy texture, which is used for soaps, and all soaps contain bases. So bases are soapy to touch. Some bases, not all, only some bases are soluble in water, and such water soluble bases are called alkali. Okay, examples are potassium hydroxide KOH and sodium hydroxide NaOH. Okay, now, bases turn red litmus blue, they turn colorless phenolphthalein to pink, and they also change the color of methyl orange to yellow. Okay, like acids, bases are also corrosive. That means they will also damage the surfaces on which they fall. Now, coming to the definition of bases, bases are those compounds which dissociate in water to produce hydroxide ion OH minus. Okay, this is the ion produced by bases in water in aqueous solutions. So NaOH in the aqueous state dissociates into sodium ions and hydroxide ions. Likewise, magnesium hydroxide MgOH whole twice dissociates to give the doubly charged magnesium ion and two hydroxide ions. Now, the chemical properties of bases. The first chemical property of base is the reaction of bases with metals, and bases react only with some very reactive metals to form hydrogen gas. They will not react with metals which are not reactive. Okay, and so sodium hydroxide reacts with zinc to form sodium zincate Na2ZnO2 plus hydrogen. This is a very special salt because it has two metal atoms, sodium and zinc. Sodium zincate is its name. Okay, the property, the reaction of acids with bases. So this is the neutralization reaction which we have studied so many times. Okay, the reaction of an acid with a base to form salt and water is, so hydrochloric acid reacts with magnesium hydroxide, they will form salt, magnesium chloride and water. Okay, the next property is the reaction of bases with non-metal oxides. So some non-metals are like carbon, nitrogen, sulfur, etc., etc. These are typical non-metals, and their oxides are carbon dioxide, nitrogen dioxide, sulfur dioxide and so on. So bases will react with the oxides of these non-metals, non-metal oxides with base, and they will form salt and water. So the oxide of carbon, carbon dioxide, reacts with calcium hydroxide and they form calcium carbonate and water. Okay, now look at these two equations, the equation of neutralization reaction with the equation for the reaction of bases with non-metal oxide. Water is same, salt is same, one of the reactants is same, base. So this should also be same. That is why it is an equation. So what can we conclude? Non-metal oxides are acidic. Non-metal oxides are acidic in nature. So carbon dioxide, nitrogen dioxide, sulfur dioxides are all acidic oxides. Okay, these are the properties of bases. Now, one property which is common to both acids and bases is the conduction of electricity. Now, electricity, you know, electricity is the movement of charges. Okay, and these charges, the charged particles can be electrons, they can also be ions, and because both acids and bases produce ions, okay, Acids produce H plus ions and bases produce OH minus ions. And when they are in the aqueous solution, they will conduct electricity because these ions will be able to move. And when ions move, we say electricity has been conducted. Okay, so there is an activity in the book on page number 22, activity 2.8. What do all bases and acids have in common? So this is the activity for the conduction of electricity. Okay, now this is the diagram, figure 2.3. We have a glass beaker here, at the bottom of which we have kept a rubber cork. On this rubber cork, 2 nails have been inserted. These nails will act as the 2 electrodes. The nails are connected to a battery with the help of conducting wires. We also have a switch and a bulb placed in the circuit. Okay, now we have to use different solutions. We have to take different solutions in the beaker which will act as the electrolyte. We can have to take glucose solution, alcohol solution, dilute hydrochloric acid and sulfuric acid. And we will take them one by one, perform the activity using one of these solutions at a time. So first we take dilute hydrochloric acid solution in the beaker and switch on to see if the bulb glows or not. We see that the bulb glows in case of HCl. The bulb will also glow in case of sulfuric acid, but the bulb will not glow in case of glucose and alcohol. Okay, why will the bulb not glow? Simply because these two will not produce ions. Unless there are charged particles that are capable of movement, electricity will not flow, the bulb will not glow. Okay, what if we take NaOH and KOH solutions? NaOH will give OH minus ions and KOH will give OH minus ions. Therefore, the bulb will glow and we say bases also conduct electricity. Okay, so the conclusion is that acids and bases conduct electricity in the aqueous state because they produce ions which will move when conducting wires are provided. Okay, now there is one more activity in the book, activity 2.9. What happens to an acid or a base in a water solution? Okay, we have been talking about the production of ions in acids and the production of ions in bases. We say acids produce hydronium ions and we say that bases produce hydroxide ions. So what is it? What has water to do with it? Okay, the activity explains it all. What do we have here? We have a test tube in which we have taken solid sodium chloride NaCl. Okay, the common salt which we use in to give that salty taste to food. On this sodium chloride we will pour concentrated sulfuric acid. This has to be done with caution because this is a corrosive acid. Okay, now we will see the formation of some bubbles, and so to test the gas produced, the reaction that takes place is we have in the test tube we have NaCl. What are we adding? We are adding acid. Okay, and so double displacement will take place, Na2 SO4 and HCl will be formed, 2HCl 2Na2SO. Okay, so this hydrogen chloride gas is released here. We will seal the test tube with a cork and allow a delivery tube to pass through it. Okay, now one end of the delivery tube we will put a guard tube. This is a guard tube. We will fix a guard tube on one end of the delivery tube. The guard tube contains calcium chloride, CaCl2. Now calcium chloride is hygroscopic. Hygroscopic is a substance which absorbs moisture. Okay, which will absorb all moisture. So the gas which comes out, which is released here, will pass through the delivery tube and then it will pass through the guard tube containing calcium chloride. Calcium chloride will absorb all the moisture from the gas, and the gas coming out from the guard tube will be absolutely dry hydrogen chloride gas. Okay, Now what do? We bring a blue litmus paper close to the guard tube, which is also dry. So we bring a dry blue litmus paper close to the end of the guard tube. Now it does not turn red, remains blue. Okay, next time what do? Instead of using the dry litmus paper, we moisten it and bring close a moist blue litmus paper. And as the gas coming out from the guard tube comes in contact with the moist blue litmus paper, it immediately turns red. Okay, so why did HCl not turn the color of dry blue litmus paper? And it turned the color of moist blue litmus paper to red. So water has a role to play. And what is that role? Because water is able to break. Because water is able to dissociate, break this bond between H and Cl, and so they will dissociate into ions. As a result, hydronium ion and chloride ion will be formed, and the properties of acids is because of the presence of this hydronium ion. Okay, likewise the bases will also dissolve in the presence of water, and they will dissolve to give, the bases will dissolve in water. They will, NaOH will dissolve in water and they will produce Na plus and OH minus ion. So water is able to dissociate the base into ions, and because of this hydroxide ions, because of the presence of these ions, bases have all their characteristic properties. Okay, now we have been talking about concentrated acids and dilute acids. In some of the activities we used dilute acids, and in other activities we used concentrated acid. What is the meaning of dilute and concentrated? It means the solution of acids with water, and how much water and how much acid, their relative concentration. Okay, so when acids and bases are mixed with water, the reaction is highly exothermic, meaning a lot of heat is liberated when acids and bases mix. Okay, so this mixing of acids and bases with water is called dilution. When acids and bases are mixed with water, what will happen? The total volume will increase, but the concentration of H hydronium ion and hydroxide ion per unit volume will decrease. Per unit volume, you understand? It is the number of ions in 1 liter that will decrease, and this is dilution. So dilute acids have less number of ions per unit volume, whereas concentrated acids have more number of ions per unit volume. Unit stands for 1. So 1 liter or 1 milliliter is unit volume. Okay, so how do we dilute an acid? Because concentrated acids can be very, very dangerous because they will have more number of ions per unit volume. So there can be two ways: either add water to acid or add acid to water. Just now we have learnt that dilution of an acid is exothermic. A lot of heat is released. So when we take acids in greater amounts and add water to it, the reaction will be exothermic. The heat generated may cause cracking of the glass. The acid and the solution may splash and it may cause accidental burns. So what should never be done? Water should never be added to acid. Okay, this is the wrong way of diluting. What else can we do? We will take water in greater amount and add acid to it slowly, dropwise, and keep it stirring constantly. We will stir the solution constantly to uniformly distribute the heat so that the glass does not break. Okay, so the correct method of diluting an acid is to add acid dropwise slowly with constant stirring to water. Alright.